How you doing today? We're in chapter 4 of water reuse regulations and guides. And I want to go through this chapter with you um, and just talk about the development of standards, regulations, guidelines. From what I understand is the federal government here in the States has not um, come up with any certain guidelines, but has left it up to the states, which is kind of the way our forefathers, I believe, wanted. So each individual states kind of have um, some power over water reuse. Like I said in previous chapters, a lot of what we um, water reuse is going on in the arid climates of the United States. So you're looking at Florida, California, and some of the other southern states. We're seeing water reuse in California, as you know, and Florida. They have a need for agriculture, because of the temperate climate there in Florida and California. They produce oranges and apricots and all that kind of stuff. And one of your questions on your homework is, what does the World Health Organization, and they actually have less restrictive um, requirements than the states, actually. So that's an answer to your question. So when we think about it, what we want to do is on page 137, factors that affect water reuse guidelines and regulations. Obviously, our number one thing is public health, right? We do not want deaths or injuries due to water reuse, whether that be, let's say we are using water reuse and we do not color code the piping. And so someone accidentally uses that for drinking or cooking processes and get sick from that. Obviously, that is a main. We're concerned about the pathogenic and also the chemical. The chemical uh, constituents of water reuse. Use of area controls. These would be our signs, color coding, pipes, fencing. Using barriers, physical or visual, so that the public knows that, hey, this is not normal well water. This is not normal irrigation water. That this is that has been wastewater that has been somewhat processed, but is being used for irrigation. Um, Environmental concerns. Our water reuse is going to negatively affect the environment. Economics. Um, each state, each municipality has to work that out on their own. They have to see, is water reuse, is it a viable economic um, way to irrigate or to supplement our water supply? And then the political realities. Once again, your city hall, your representatives, your state legislation. It's are the people going to get behind this program of water reuse? When we Some of our main concerns are on page 139, and that's the micrological and chemical constituents and the physical properties. So on page 140, you have your bacteria, your protozoa, your viruses. Is this water that we're using for reuse, is is it disinfected enough where the bacteria is not going to be harmful, or are we using the water reuse in a way that the public is not going to get endangered? So, when we use it on, like, let's say, a golf course, right? Are we going to provide the adequate disinfection so that if a guy wears his shoes home, and tracks through his house from playing on the golf course, is his child going to get sick from what is on the bottom of his shoes? Chemical constituents, just let's say a factory was in our municipality or our county system, and it was putting high levels of metals or TDS or disinfection byproducts down the drain, and then we put that on somebody's crops, right? Do you want to be eating those crops? We want to make sure that, 15, 20 years after kids or you have digested these crops, that we're not causing some sort of cancer. Temperature is physical properties, temperature and turbidity. Turbidity, you know, it can blind the disinfection process, and the temperature, if the temperature from, let's say we're using water from a cooling tower, if we discharge that to the environment, is that going to negatively affect the microorganisms in that ecosystem, right? So moving right along, groundwater monitoring. It's very important that if we are using some sort of water reuse for irrigation, or let's some other recreation, that we are monitoring the groundwater, right? We want to make sure that we are not um, taking our water, reuse water, and contaminating a larger scale of water that's already in the ground, right? Um, Page 149, crop contamination, right? We're worried about uh, spraying water, water reuse on crops, contaminating them to the point. We also need to be very important. Is that crop going to be used for human consumption or for another consumption, indirectly um, uh, consumed by animals and then by us? Uh, Page 150, we want to look at levels of public access, right? So, as we talked before, a park, a cemetery, a school grounds, residential lawns, that they're going to have a higher level of access versus, let's say, a farm field, right? That not a lot of people are walking on a daily basis, or should be walking on a daily basis. And even if they are, maybe some signage would be appropriate. Accumulation of trace chemical constituents, right? Like we want to see um, how much chemicals um, are building up in the crops. So I know for my municipality, we use our biosolids and we spread, and the EPA monitors that, and we're only allowed to put so much metals on a field before we have to start, going to a different field. So sludge biosolids, by its nature, has metals in it, and we just want to monitor that we're not putting too much metals onto the field. Um Dual systems in building uses. That's if you don't use water reuse, you'll have a dual system. It should be, and basically that's two sets of pipes in your house or your building. One is to be used for water reuse, and the other is for drinking. So you can use reused water, perhaps to flush your toilets, maybe even take a shower, or some other boiler makeup process in there. But that will be labeled one way, and then there'll be a second set of pipes that will be clearly labeled, that will be not for public consumption. We talked about, uh, we'll talk more about health risks associated, right? There are studies that we can do to see how is this substance going to cause problems, acute or chronic. Is it going to cause, if someone's exposed to it, is it going to cause problems in the short term or long term, develop cancer? On page 159, you can see kind of a summary of the state water reuse and regulation guidelines, right? You can see each state has its own. I'm sure this has probably been updated, but you can read through there. Um, Examples on page 162, examples of state water use regulations for non-potable applications, right? So, for let's say Colorado, right? You're only allowed 200 fecal counts per 100 mil, and that's for fodder crop irrigation, right? Um, and then for like food crop uh, irrigation under Colorado, it says not covered. In Florida, it says use prohibited. So, for in Florida, for food crops, it says use is prohibited. Moving along. Once again, for one of the questions, the US EPA guidelines for water reuse, that's on page 169. The World Health question, I have written down here 6. That's on page 179. Um, so that's a brief synopsis of chapter 4. Just some of the factors that affect water reuse. Thank you.